In this video, we're going to talk about how to factor trinomials with a leading coefficient of 1. So, when we have a trinomial with a leading coefficient of 1, remember that we just have x squared, no other number in front of it, which means there's really a 1 here. And then we have our x term and our constant. So the way that we get a trinomial with a leading coefficient of 1 is when we multiply two binomials together, like let's say x plus 3, x minus 5, and they both have a leading coefficient of 1. So if we were to FOIL this, we would get x squared minus 5x plus 3x minus 15. And then remember, we have to combine the middle terms because they're like terms. So this gives us x squared minus 2x minus 15. So in this case, b would be negative 2 and c would be negative 15. Now if you look at what we started with, the way that we get the negative 2 is by adding the 3 and the negative 5 together. So 3 plus negative 5 gave us the negative 2. And the way that we get the negative 15 is by multiplying the 3 and the negative 5 together. So 3 times negative 5 is negative 15. So this is what's always going to happen in trinomials with a leading coefficient of 1. Whatever these numbers are along with our x's, we can add them to get b, and we can multiply them to get c. So understanding how we get these trinomials with a leading coefficient of 1 is going to help us factor them. So in this case, b is positive 7 and c is positive 12. So remember, this is going to factor into two binomials that both have just an x. And then I'm looking for these two numbers here with either a plus or a minus, depending on if they're positive or negative. And remember from what we talked about a minute ago, that whatever the two numbers are, I have to be able to multiply them together to get 12. So I'm going to start by looking at factors of c, which is 12 in this case. So my possible factors are 1 times 12, 2 times 6, and 3 times 4. Now I want the factors that are going to add to equal 7. Well, if I add these two, I get 13. If I add these two, I get 8. If I add these two, I get 7. So these are my factors. They're both positive. So this binomial will get the plus 3, and this one will get the plus 4. And it doesn't matter if you instead wrote it x plus 4, x plus 3. Remember, if it's multiplication, then the order doesn't matter. We can easily check this by FOILing. So x times x is x squared, x times 3 is 3x, 4 times x is 4x, and 4 times 3 is 12. When I go ahead and combine those middle terms, I get x squared plus 7x plus 12, which is exactly what I started with, so I know this is the correct factored form. Okay, in the next one we have x squared minus 6x plus 8. So again, this negative 6 is b, and this 8 is c. And this is going to factor into x plus or minus something, and then also x plus or minus something. So these are my two binomials. So I'm going to start by looking at factors of c, so factors of 8. And I'm eventually going to look for the pair that equal negative 6. Well, the only way I can have a positive number is by either multiplying two positives or two negatives together. And since b is negative, that tells me both of my factors have to be negative. So I can either have negative 1 times negative 8, or negative 2 times negative 4. And again, I'm looking to see which one has a sum of negative 6, and you can see that this is our second grouping of factors here. So this will factor into x minus 2, x minus 4. And again, we could very easily check that by multiplying. X times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. So when I go to simplify this, I get x squared minus 6x plus 8, which is exactly what I started with. So I know that x minus 2 times x minus 4 is my correct factored form. Now in this next example, the first thing you should notice is that my polynomial, my trinomial, is not in descending order. So I'm going to go ahead and rewrite it so that it's in the correct order. X squared minus 3x minus 10. So that allows me to see that b is negative 3 and c is negative 10. So this time I'm looking for factors of negative 10, which means one has to be positive and one has to be negative in order to make that a negative 10. Now since b is negative, that tells me my bigger factor has to also be negative. So my options would be 1 times negative 10 or 2 times negative 5. And again, I'm looking for the factors that would add to equal negative 3, and that would be the 2 and the negative 5. So that means my trinomial factors into x plus 2, because it's a positive 2, and x minus 5, because it's a negative 5. And again, we can check that by foiling, and we would get this trinomial right here that we put in descending order. So this next example is slightly different because we also have y squared and a y in it. And that's fine. We're going to factor it the same way. So in this case, b would be 10 and c would be 25. So we're going to look for factors of 25 that add to equal 10. So our factors of 25, since b is positive and c is positive, we know that they both have to be positive. So I could only do 1 times 25 or 5 times 5. So we can see 5 times 5 would add to equal 10. So normally we would factor this into x plus 5 times x plus 5. The difference now is that we have to end up with 25y squared. So the way that we're going to get that y squared is just by multiplying y times y. So if we FOIL this, we get x squared plus 5xy plus 5xy plus 25y squared. We combine our middle terms and we get x squared plus 10xy plus 25y squared. So we know that this is the correct factored form, but because those two binomials are exactly the same, we would write this x plus 5y quantity squared because we're just multiplying something by itself. So this would be our final answer right here. In this next example, you can see that we have a negative leading coefficient right here. So remember, we always want to factor out a negative if our leading coefficient is negative. So we're going to start by factoring out that negative, which is going to change the sign on every term in the trinomial. And then we have to see if we can factor this trinomial any further. So in this case, c is negative 12. There's really a 1 in front of this x, so that's b. So we're looking for factors of negative 12, which means 1 is positive and 1 is negative, which add to equal positive 1, so that tells us our bigger factor is positive. So we can either have negative 1 and 12, negative 2 and 6, or negative 3 and 4. we can see that the negative 3 and 4 will add to equal positive 1, so this will factor into x minus 3 times x plus 4, and then we can't forget to include the negative that we factored out at the very beginning. Okay, so when we first look at this last example, it does not have a leading coefficient of 1. But remember, whenever we're factoring anything, we always need to start by checking for a GCF. So all of these are even, which means I can factor out a 2, and they all have an x in them. So I'm going to start by factoring out a 2x. That will leave us with y squared plus 2y minus 15. Now, just because I factored out a GCF of 2x here doesn't mean I'm done. I have to continue factoring this trinomial. So in this case, b is 2 and c is negative 15. So I'm looking for factors of negative 15 that add to equal 2, positive 2, so my larger factor is positive. So I have negative 1 and 15, or negative 3 and 5. So this is the pair that gives me positive 2 when I add them together. So this will factor into y minus 3 times y plus 5. And then I need to include my GCF of 2x that we factored out at the very start. If I don't, when I go to FOIL and check, I would get a different answer than what I started with.